Hello, everyone. How's it going? It is November 30th, 2023, and I'm doing a day stream. I'm trying to see if I can get my setup working. I have this new camera. What do you guys think? Anyone see it? Does it look okay? This is mainly going to be like a test out stream. I don't have much planned other than hanging out and answering questions. Now, if you're watching on YouTube, I would like you to click the link and watch on Twitch, and that's the way I'll be checking out the chat. So I don't want there to be multiple chats, basically. It's been confusing in the past, and I want to make it more streamlined. So I'm going to pop out my Twitch chat here, and pretty soon I'm going to be changing up to being there. But if you don't see that link, let me know. Or if something else is messed up, can't hear something, let me know. What's on your mind? Let me know in the chat. Let me know what's going on. Let's see if it'll pop up here. If anyone, maybe I should just test it. Let's test it. Hey, someone's following. Welcome to the family. New follower. So I was thinking we'd do something with data science, data analytics, using Python, the regular good old stuff that we're used to doing on my stream. And I can test out things as we go. So if it's a little choppy, please let me know. Hey. And then we'll go to Twitch. Okay, I should probably share my screen, okay? Here we go. Oh no, that's not working. Good thing we're testing this out. Okay, now it's working. What happened there? So yeah, let's go ahead and make sure that you guys can see what's going on. I have some code here, and we're just doing an AMA about data science and coding. Coding questions. I'm going to make a new notebook here, and we're just going to talk about coding questions. There we go. Let's get the chat window here. Can you see it? No, you can't. So maybe I should do this version. I think this looks a little bit better. And then I can pull up the chat menus here. Hello? Is this working? Yes, then it appears on the screen. Okay, so make this bigger, I guess. Hey, okay. Fauline, how's it going? Okay, people are first time chatting. Welcome, welcome, welcome. How's it going today? Oh, I need to make this a green screen. All right. Is that work? Is that working? Hopefully you can hear it now. Oh, and I didn't put yeah, so my audio sources do not exist on all my different screens. Okay, now you should be able to hear it with a little bit of music in the background. You should be able to see the chat up there. I also have it here. All right, I'm getting the hang of this. It's only been a few years that I've been streaming, and now I'm just starting to get the hang of it. Look at that, my shirt matches the background. So what do we want to talk about? So I get a lot of questions on our Discord channel about very specific things, and I know I didn't prep anything or put out anything saying I was going to stream today. So maybe maybe there aren't people out there with questions ready to go. But if you guys have anything you want to talk about, let me know. If not, I want to show you guys something new that I've been using a little bit of that was released not too long ago, and that's this cuDiff updated cuDiff library. So if you're not aware, I use the package pandas a lot on this channel, which is like a data manipulation and a tool for working with data, basically like spreadsheets, but programmatically using Python. And cuDiff just announced that they have a no-code change. Like basically, cuDiff is your ability to run those data frames, but on your GPU, which can make things a lot faster in certain situations. But they really updated it. So now all you need to do is really add one flag and you should be able to run things a lot faster. So we could test this out if you guys want. I think that'd be a good idea to look at. And then answering any questions you guys have, which are none. So let's go ahead and test this out. Now, I don't know if I have that installed on my local machine. Let's see here. This might be fun to see if we can get it set up. All right, so they have this example. So let's just do normal old pandas and make sure I can get this to work. So pandas, right, lets us read in files. So a CSV, this one's hosted on GitHub. And we can make a data frame out of that. Okay, so they're giving us an example data frame here with, oops. Have you tried Polars? Yes, I wonder how it competes. Yeah, I should do a competition between them. I do have a video out on Polars. So if you look up on YouTube, if you search Polars YouTube, I think mine's the first one that comes up, but where I kind of go through Polars versus pandas. When you're doing like legit pipelines that need to be fast, Polars is almost always faster. But there are some reasons why I still fall back to using pandas a lot of the time. The main reason is that pandas, I'm just familiar with the syntax a lot more, and you can quickly do plotting and exploration that way. If everything can fit in memory of the computer and the data set's fairly small, I haven't found a big reason to switch over completely. But using this cuDiff extension is supposedly what will give a boost without having to learn that new syntax. Still, Polars, I think, is slowly but surely becoming more prominent. I've seen it a lot in Kaggle competitions. So especially the one I'm working on right now, the data is a little bit too large to fit into memory, and you can use this lazy evaluation, which really helps make things go a lot faster. So another data nerd. Nice. Yeah. Hey, welcome, Maddie. Nice to have you. Can you do videos on research paper implementation, end-to-end coding? Would really help, especially for people starting out. Yeah, I mean, the research papers vary so much, but usually in the course of a Kaggle competition, I will read a handful of papers and implement some of them. So, I mean, just one example. So this is a single pixel attack. I guess this isn't like a true data science project, but on the last stream, I talked about the solution to the DEF CON competition that I worked on. And one of the problems in that was trying to use a single pixel attack for fooling deep neural networks. So basically, I found this paper and I tried to implement it. I used ChatGPT actually to help actually implement the algorithm that they were using. But I'd say a lot of times especially when you're looking at deep learning papers, you want to read like of course you want to read the abstract and get a good idea of what's going on with it and maybe the conclusion, but then also looking at just the architecture of the model and how they have it set up. Papers with code are a lot easier to follow because you can actually implement it. But after a while of reading the papers, if they do a decent job of explaining what their model looks like, you can kind of copy it and do an implementation either in PyTorch or TensorFlow. Yeah. I've used Feather format to store data. Yeah, so I have a video comparing Feather, Parquet, HDF5, CSV, obviously. So for those of you that don't know, when you have a pandas data frame like this, right? We read this from a CSV. This is a comma separated values file. So if I so let's go here. The nice thing about CSV files is you can just take them and open them with Excel or whatever. So if I just get this tips CSV file, it's just going to download it locally. And then we like run a head command on the actual tips CSV file. It looks like this. So each line is text and the separation between them is a comma. Other than that, it's like Unix text straight up on that we're using here to save the data, right? That is nice because it like we can open it with other programs, but when the data gets really big, this is a really inefficient way to store our data. So if we take this CSV data frame like we have here, now it's read into Pandas, we can save it as a bunch of different things in Pandas. You could save it to a CSV, obviously, same way. Excel format even. Here's Feather. Let's do tips.feather. Or my personal favorite, Parquet. And each of these has its own benefits, right? Now the thing that we don't, let's just get some empty space. So the thing that it doesn't have is the benefit of being able to read the raw data. Because now if we look at the Feather file, we see like there's some metadata here, but it's actually compiled stuff that you can't read just with a text editor. Or same thing with Parquet. If we look at the top of this, and running this head command is kind of equivalent to if I just went into this repositories directory, Twitch, and what's my here. So here are the files. If I like open it up in Vim, this Feather, it's just going to look like a jumbled mess. Right? Feather, I think, is supposed to be more lightweight, obviously, with the name Feather. For smaller data like reading or writing, I just end up using Parquet for almost everything. It just works well. It saves the metadata. It saves the data types. So when you're reading from a CSV like this, it doesn't know, especially with dates and things like that, it doesn't know what data type each of these are. So male, female column, it stores this as a string, but let's say if we make this as a categorical with two different types. If we save this as a CSV and read it back in, it's still going to think this is a text, like a string column. So the nice thing with Feather and Parquet is, okay, so I saved it and then I reread it from this Feather format. If we go to this sex Column, we can see the category. It's still categorical. So it's actually saved that information when it's written it to disk. So big benefits to using Feather or Parquet or whatever. Did he just say Excel? I did say Excel. Excel is not always bad. There's some times when you want to use Excel. What do you think of neural audio synthesis? Have you explored there? It blends data science and signal processing. I haven't looked at neural audio synthesis. Okay. Tell me more. Tell me more. I'd love to know more. Happy watching everyone. A good stream to you, Rob. Thank you. Welcome. Thanks for being a first-time chatter. SQL. Okay, you like SQL? You can run SQL on CSV or Parquet files really easily. You can use what's it called, DuckDB, to read from files like it was an SQL database. So there are a lot of benefits to that. Thanks for being a good teacher and sharing your knowledge. Thank you. Please ask questions. Rob, thank you for dedicated. What would you do? What would I have to do to be hireable for big companies? Any advice? You need to stand out somehow. You need to stand out. You need to show you're passionate, and then you just got to get your foot in the door. So making connections is actually pretty important. If you apply for a job, and you have someone refer you in the big company, it automatically gets you around. It gets you through to that first phase, usually. So unless you get to that first phase, and a lot of that's automated nowadays, you're not going to be interviewed. So making connections is important. And you can do that through projects or through Kaggle, all that stuff. Thanks for the info on Feather. Would check out Parquet as well. Yeah, definitely check out Parquet. Again, I have a YouTube video on this. If you look at my channel, which one? This one's on pandas. Parquet. Will it let me search here? Yeah, this one. It's not the best titled video, but yeah, this is all about how you can use Parquet and other data formats that are a lot faster than CSVs. Hey Rob, happy to catch your stream. Here's my question. How much ML ops do you think data science ML engineers should be able to know? I always have been doing Kaggle and set that part aside. By the way, tell us what you're currently doing with NVIDIA. Delay, thanks for asking. What do you mean currently doing with NVIDIA? They were really nice and had me join them for their summit. And I was on a panel with Christoph and Mikkel, who are both Kagglers. And that was really fun. Also, I was in San Francisco not too long ago for H2O World, where we talked about a lot of open source stuff that's going on. Rob, Jedi or the Sith? I gotta go Jedi on that. Where is often the place where data analysts or someone working in data science should show themselves? I find the use of GitHub strange for data analysis projects. What's your opinion? Yeah, I think that Kaggle is pretty good for that. I mean, if you're gonna, the thing about Kaggle is it's sort of public, right? I mean, it is. You can make your notebooks public, so you could do all your notebook coding publicly. But you also get feedback from people. Like it could be really highly upvoted, so you're getting immediate feedback. Where's my code? Let's see. And the other big thing is then someone could actually take your code and run it themselves. So like this is one of my most popular notebooks. If you search, my name might come up on Google or something. But you could see that I was able to write all this code, and you can actually just copy it and edit. I think if you were running this, you could just copy and edit. So I think this is a good place to kind of make a portfolio. It's definitely not the only way to do it, but there are a lot of benefits to doing it here. Now, the nice thing about GitHub is if you're working with people who are, you know, not necessarily only into data science, they might prefer seeing what you're doing on GitHub. I don't know. Do I have custom key bindings for Jupyter? No, I just use the default ones, but I use them a lot. Like the big ones that I use a lot are getting used to J and K to jumping around, which is nice because J and K. So if you escape out of a cell, like, hello, I'm in this cell, right? And you're editing in this, and then I want to escape out, I just hit escape, and then I go J and K to go up and down. DD will delete a cell, so let's go in here, delete this cell. And then I can just delete it by hitting DD twice. B will add a cell. What else? Oh, I could change this to markdown by doing escape and then M. There's a lot of stuff that's nice with that. And if you're a fan of Vim, so the nice thing is that J and K and moving around like that is similar to working in Vim, right? So oh, wait. So this is a script now that I'm editing in Vim, or if you use Vim key bindings in other stuff, then that J and K stuff is already natural. Like I'm using J and K to move up and down. But yeah, I find this really helpful. And especially when I'm iterating over things and I want to like test up here, move down to this cell, and then back, or plotting things, or copying this cell now into here and then deleting this one. Like never taking your hands off the keyboard is key. They say that about a lot of stuff with coding, right? Massive Vim fan. Nice. Yeah, I dedicated the time early on to at least getting good enough on Vim that I could like move around, especially when you're working on remote servers and they don't have anything installed and you can't SSH into it and like forward ports and stuff. If you're just able to open up VI, it's on every Linux machine. So then you can edit a file real quick. Thanks for YouTube videos started. What does this say? Started watching them when I was a complete noob. Helped a great deal. I'm glad, Absit. I'm glad they helped you and glad you're here. If you conducted an interview, what would be possible questions? It's been a while since I conducted an interview, but there was a time when we did a round of interviews, and I remember some of the questions were SQL specific. Some were just more general. I think that a lot of the good problems. So we approach it a certain way. So a lot of the good questions I think are just broad enough that you're just listening to see how the person approaches a problem. So if you said like, we want to model traffic in a city and we have these data points, or what type of data points would you want to explore or to model these interactions? Then you just let the person talk. And then I think there's usually like just a proficiency coding evaluation to make sure the person can write the Fibonacci function, or that they can, do some basic coding. So I think if I was to interview someone that I didn't know at all, and I didn't know their background, I would ask those, I would kind of follow that same structure. Yes, I finally found you on Switch. Your previous count seemed to not work. My previous count seemed to not work? What does that mean, Mike? Oh, account. Yes, I switched my name. So I used to be Medallion Stallion, and now we're on, now my name's Rob Codes Live. Yeah, so go follow me on Rob Codes Live. I think if you follow me on Medallion Stallion, I'm still on Rob Codes Live, but I thought maybe when you change your name, it would forward you to the new one, but now it doesn't. It just goes to nothing. So it makes a little bit more sense to have my username something that like relates at least a little bit to coding, since that's what we do here. What else we got here? Oh, nope. That's Slack. I gotta get better at jumping back and forth. You like my vid on sentiment analysis? Yeah, sentiment analysis is pretty cool. And it's nice how quickly you can do it out of the box with some of these Hugging Face models that are just there. Working with my team on an NLP project right now. Oh, what are you doing something with sentiment analysis? Sure, you'll do well. There's a new section on LeetCode for Panda. What's my opinion on LeetCoding? I haven't done enough of LeetCoding, but I should check that out if there is a new section. I'm surprised there wasn't already. Now I have a little project on Streamlit. Would you mind checking it out? Maybe? Sure. Twitch and naming is just weird. Yeah. So let's look up LeetCode. I don't know when's the last time I've been on LeetCode. Will this let me sign in? Switch to here. See if I can get into LeetCode and see this pandas section. Oh, I forgot my password. I thought it'd be linked just to my email. We're trying to get into LeetCode to see if we can do some pandas. Sign in. Whoop, there it is. Okay. Okay, I'm already logged in. My name is user539. Let's see this. This is LeetCode. Help me out here, people. Pandas. Introduction to pandas. 5 questions. Let's see if I can do it. Try it out. Is there a dark theme, a natural dark theme that I can turn on? Layouts. As you can tell, I haven't spent that much time on LeetCode. In one of the challenges, I came up top 500. I kept trying to increase my score with tuning the model parameters, but at most changed 10 points. I could not increase my score at all. What am I doing wrong? One of the best things you can do when you're not sure why you're not improving your model, especially on Kaggle, is to create, depending on how big your model is hopefully you've trained your model on a portion of the training set and you've held out some as the validation set. But you can actually do full folds. I have a video on this too, on model validation. But you do full out of fold predictions, and then you do some analysis, some EDA of what you're doing wrong in your predictions that score poorly and what you're doing right in the ones that score well. And usually that'll spark some creativity, some ideas for me at least, as to what to improve. But then I also sometimes reach the point where it seems like there's nothing I can do to improve it. Hey, Rob, do you have a YouTube video on how to install CUDA toolkit? I've been trying to use cuDF and cuML. No, I should make a video on that stuff because it does heavily depend on your OS. Like if you're on Windows, it's going to be different than me on Linux, or on a Mac where you probably can't do it because you don't have an NVIDIA card. But yeah, it can be tough. I would just follow the instructions online and then search up any issues you have, or ask ChatGPT. It can help a lot with that too. Any thought on topic modeling, how to get started with text processing steps for text analysis? So yeah, LLMs have kind of taken over a lot with this stuff. A lot of open source LLMs where you can just feed it the text and ask it. Yeah, you guys like the sentiment analysis video. Maybe I need to make more videos like that. It was fun to make though. Yep, with Bert, Roberta, and some other models. Here's a link to someone's project. Hopefully this isn't a virus. Welcome to my data science project about running. Nice. Data frame head. So you pulled your data from Strava. Nice. I have my Strava data as well. Summary stats, visualization, correlation matrix, regression plot. Yeah, this is all like very good starter stuff. Oh, and the fact that you made this is nice. So in this part, we will train a random forest regressor. I'm not sure why it all just got darker. Maybe that's just my browser. In the menu below, you can choose some options to tune the model. What are you predicting, though? What are you trying to predict? Your heart rate, maybe? Maybe that could be more clear in this. Oh, predicting pace for your training. How do you know if this pace is preferable? It's just you're running a regression against your data, but then you're saying that it's preferable. Maybe you're running not the correct way. I'm not saying you aren't, but you might want to take it a step further in thinking through that. But other than that, this stuff is like, I think that when you're exploring data yourself, running a head command on the data frame obviously is helpful, but when you're doing a presentation, maybe not when you're presenting it. But otherwise, great work. Great work. Any advice on how to increase contact tech recruiters in LinkedIn data science and analyst? I don't have great advice on that, unfortunately. I get too many messages already with things I'm not interested in. So I have the opposite problem. Can you explain how to show the logic of data scaling? Why do we need to do this? That's a good question. All right, so before we dive into, you just need to turn that off here. Before we dive into, and I'm going to delete this stuff because I don't know if we're going to do the CUDA stuff today. Maybe we'll look at that in another stream. I'll prepare it. Before we dive into LeetCode, let's talk about data scaling since someone asked about that. All right, so let's take a bunch of data. Have I imported NumPy? No, I haven't. Let's import NumPy. And we're going to make a bunch of fake data. We're going to do like a uniform distribution between -500 and 124. And we're going to make the size 1000. And that's our raw data, right? Let's make this into a data frame so that we can plot with it. And our column name is going to be value. So if we look at this value, if we look at a histogram of this value, we could see that it's just a uniform distribution of random values between negative 500 and 100. Let's say this is actually feature 1. And then let's make a second feature called feature 2. And this is just going to be a normal distribution between negative 20 and negative 10. Oh, this is a location in a scale. That's like the standard deviation, let's say. All right, so our data is going to be F1 and F2. So that's feature 1. Feature 2. Why am I doing this? To show you is this not going to work because of this? Oh, that's right. Let's transpose this and then make our column names this. So very long-winded way to explain why we want to do scaling. Okay, so let's look at these features and we could see that the distribution of them, if we plot now the features, both features in a histogram, we're going to see that they're on completely different scales. And there's a lot of times you'll see this in your data. You know, feature 1 is like negative 500 to 125. The feature 2 is just around here. Now, if you're using a model, if you're using these as features into a model, and the model is already going to create is something like a tree-based model, then it's going to cut these features. It's going to cut these numeric features into different bins or groups. And it's going to do that mostly automatic. The model will figure out where to cut that. But if you're using something like a deep learning, a neural network model, it's not going to actually make these discrete cut points. It's going to be firing neurons based on the input data. Now, can the models learn this differences in feature distributions? Yeah, the deep learning models can probably learn it, but it'll help it a lot more if you scale these to make them normal. And usually with deep learning, you're going to scale to 0, between 0 and 1, or negative 1 and 1. And you can do that a few different ways. Like you could just take feature 1 and we could take the average value of it and subtract the average value of it and divide by the standard deviation. Right? And now if we do this to both of these, feature 1 and 2, I need to be reading chat too. Now if we plot these, the model's going to have a lot easier time with figuring out where to do these cut points. So let's do some alpha on this. All right. Advent of code. Oh, I need to look at advent of code. Personal portfolio, or someone was doing audio classification. Okay, so this is standard scaling, and you haven't really changed the order, I guess, of the features. but you've just scrunched it so it's between a certain range. Now you can see that doing it the way I did doesn't actually make it between -1 and 1, but at least it makes that, like, it's nice to have the average around 0 and then like the standard deviation to be kind of within 1 or 2, and then the model can usually deal with that well. But usually what we use to do this is, instead of doing it manually like that, is from sklearn pre-processing, import. You could get like a standard scaler, or there's a robust scaler, or there's a min-max scaler. And these all do different things, and you'd be they're slightly different ways of scaling, and you'd be surprised what a big impact the different type of scalers will have on your model. And it kind of depends on your data set. So if we take this standard scaler and we run a fit predict on our feature 1, right? Oh yeah, fit transform, since this is like a data transformation, and maybe we want values here. Okay, it needs it to be a 1D array. So I think we can do this like this. And let's call this feature 1 standard scale. And we can look how the difference between these look. Pretty similar. I think standard scaling almost does the exact same thing as what I did. If we look at the documentation for standard scaling, we could see that it, subtracts the average value and divides by the standard deviation. But instead, let's do something like, let's use a min-max scaler. And let's look at how that scaling is different. Right? So this actually did now. Min-max scaling will scale between 0 and 1. So you can see how the distribution has now changed. These all will impact how your model learns. Now, most deep learning models will learn the differences anyways, but especially when your data is kind of small. Another thing to keep in mind is you can change some parameters in this. So this is like a feature range. We could make this from -1 to 1. Got to close our brackets. And now you can see the distribution has changed here. Like, yeah, so a lot of different ways that you can use these scalars that, again, for deep learning approaches matters a lot more than if you're using a tree-based algorithm. If you're using a tree-based algorithm, then it doesn't really matter because the cut points are going to be made regardless of what the values are scaled to. It doesn't really hurt, but hey. What range do you take to scale features? How much difference is needed between values? Or do it every time to prevent problems? I think it just depends. And it's also more about consistency. So if we look at like, if we look at something like that, a real life application of this, if we're looking at a model that's used like a deep learning image classification model, MobileNet, they have a pre-processing operation that's used. And the way the normalization works in images usually is you're doing that same mean and standard deviation, standard scaling of each channel individually for the image. So actually I was working on this recently in that competition that we did for DEF CON. And the scaling values were different between these two different versions of the model. So if you were using one model weight, you needed to make sure that your input data was scaled correctly, like this way. And look, this scaled from 0 to 1. I think that the TensorFlow version of this model might have scaled from -1 to 1. So again, it's not that big of a deal if what the range is. You'd like it to be a lower number, a floating point number, but the bigger deal is that you're consistent. So if you train a model on all images scaled from 0 to 1, and then you try to run inference on that same model, and it's scaled from -1 to 1, the model's not going to perform very well because it's not expecting the data to be like that. Hi, everyone. Hi, Rob. How are you doing? I'm doing great. I'm doing better now that you're here. See how Twitch is doing. Well, we have like more viewers now than I think I've ever had, or getting up there. Thanks everyone for hanging out. Hey guys, I started my first data science project scraping local gym utilization data since February to predict future. Does anyone have any tips or resources I should look up? I do have a video. I have 2 videos on YouTube on time series predictions. The thing I'll say about doing time series forecasting is that it's very easy to overfit your model and to become overconfident of how well it's actually doing. So doing some sort of validation is really necessary. And also some forecasting is just, always wrong. All models are wrong, but a lot of forecasting models, like it's impossible to predict. So the problem I would assume with what you've just said is that you've scraped local gym utilization data since February. So that means you're going to have less than 1 year of data. And having less than 1 year data means that you're not going to be able to pick up on seasonal trends. Ideally, you would have like 5 or 6 years of data. Now, keeping in mind that COVID's going to affect those years when all the gyms were closed and that stuff. So a lot to consider there. But if I were you, I would try to get a little bit more. If you had 1 year of data and you have multiple sites, then you could at least cross-validate between sites. Have you given a shot to Optivert competitions? I haven't. Those are mostly like predicting the stock market, right? I don't find those extremely fascinating. And the thing is about those algorithms is, in order to make money on them, you need to be a big operation that can run these huge computers right next to the stock exchanges. So I don't know. A lot of them also seem like a little bit of luck. Ever consider making a guide on TensorFlow for people who are switching from other frameworks like PyTorch? Are that many people switching to TensorFlow from PyTorch? Because I thought it was the other way around. That's why I made a tutorial on PyTorch. But hey, if you guys are telling me otherwise, Pragato. Yeah, the thing I'll say about PyTorch versus TensorFlow is it's a little bit overblown what the differences are. Especially when we're talking about like TensorFlow 2.0 and PyTorch 2.0. Like in TensorFlow, now you can just like you're basically just working with tensors. Just like before we were working with NumPy arrays. This is our torch tensor. And let's do our TensorFlow tensor. A little redundant to say TensorFlow tensor. But the syntax is a little bit different. No, watch that. I think I do from array, maybe. Watch this. Like at even TensorFlow create tensor. My point is, it's all just operations that you can run just like NumPy, but you're doing it on your GPU. So yeah, okay, so we can make a constant. I don't think it'll take a list, so we might have to wrap this with an array. Oh no, it did it. Okay, so now we have a TensorFlow tensor. We have the dimensions. We have a PyTorch tensor. We know the dimensions by just doing .shape. So if we wanted to like invert this, I don't know if I could just do this. Basically, the operations that we do on it, the syntax is going to be a little bit different, but like transposing, can't really transpose one dimensional. What really matters, my point is, what really matters is that you understand how the tensors are being manipulated and what you're trying to do with them. So if I'm like trying to expand the dimensions here, now this is my TensorFlow tensor, and I do this unsqueeze, dimension is 0. So now the shape is going to be 1/4. Doing this same unsqueeze, I think in TensorFlow is expand dimensions. So you have to do it like this. But the tensors are exactly the same. You just have to learn these different syntax. There's a lot more to it, especially when you get into like Keras, and then you start like saying, oh, okay, I'm only going to use PyTorch Lightning or something like that, or Keras. But everything underneath is the same. You can actually take the model weights, move them from one model to the other. It should operate the exact same. Doesn't always, but should. Because Kaggle got better TPU support for TensorFlow. That's true. That's one thing that although PyTorch can, I know PyTorch Lightning can support TPUs. It just out of the box works a lot better with PyTorch. With Keras, you can always now use PyTorch, which is cool. Yeah, Keras, now you can use a different backend, right? I don't really know. JAX, I haven't spent enough time with. I think JAX is probably good, but I just haven't used it. Does clustering become popular? So clustering is popular. Clustering is kind of like one of the most popular, other than like generative models. Clustering is one of the most popular ways of taking like data and doing analysis on it. That's not, what am I trying to say? Clustering is one of the most popular ways of doing modeling where you don't have a target, unsupervised machine learning. So you're trying to take a data set and understand how it groups together, and you're not necessarily trying to minimize a specific loss function for a target column in the data. You're just trying to understand it better. So sklearn has some really good clustering algorithms, like the standard one, like k-means. And then we can run fit predict on, the thing is that it needs to be all numeric data. What's the size of the tip? All right, so we have this data that's a bunch of tips data. There's 244 of them. We have to set the number of clusters. Let's just make it 2. Oh, I didn't save those columns. So I find this is mostly helpful when doing like exploration of the data, not so much when you're actually, maybe as feature generation. So now it's run this algorithm to try to predict. I could go into detail all about the algorithm, but we'll save that for another day. And now we can see that it's clustered this data based on the features that we gave it using the k nearest means algorithm to put this in different clusters. And if we group by these clusters and do something like look at the total bill and plot a histogram. Now this is relatively small data, so we might not see it, but we can actually see the clustering did like make the smaller bills into one cluster and the bigger bills into the other. Or a better way to do this is import Seaborn pair plot this data frame with these features, and the hue will be the cluster. Let's see if this works. Yeah, so now we can kind of see how the clustering algorithm decided to split this into two clusters. This data set's not really a good one for identifying two clusters, but you might imagine a data set where you did have that and you want to kind of group your population into two different groups or 5 different groups or whatever. This is really popular. Then there's something called like TSNE, which I don't know, good for visualizing also. But the parameters that you use can really affect TSNE. I like the idea using Notebook as a sort of whiteboard works quite well. Thanks. Yeah. What's the best way to work with very high dimensional data sets and do EDA? I have a data set with 3,000 plus columns. Most of it is 12 months catch results, for example, and I'm finding it hard to work due to size. Would you break it down into smaller data frames by grouping and filtering data? Okay, so that's an interesting example. So we have, when you think about the data shape of a data frame, let's just assume we're talking about data that has columns, which you could say are equal to like features, and then rows, which are examples or items in the data set. There are commonly you'll have like big data sets, but the big data sets are big because they're really deep. There's a lot of items. So you can see the shape of this data frame has 8 features and 244 examples. But what if you had 244 features and only 8 examples? One thing that's pretty common is you could take each of those features and you could see if they actually contain any information that relates to your target. So you could just run like a logistic regression on each of them to whatever feature you care about most. And if some of them are just all noise, you can just drop them. That'll help you minimize it. Then you can also do if you want to be more complicated, you can do something like principal component analysis. And this is just basically a method of taking highly dimensional data like what you're talking about and making it into less dimensional. So taking 4,000 columns, like you said, and making it into however many, 10. The problem with that is that then you lose the details of each of those features. So it's a trade-off. Rarely, though, is it necessarily important to use that many features because unless your data is, so in machine learning, unless your data is deep enough to really capture what's going on in all of those features, usually it's a best bet only to use features that are helpful in your modeling. When your data gets huge, like absolutely humongous, that's something like image data where actually each pixel in the image I guess is you could say is a feature. Then you need like millions of pictures in order to really train these models to do good classification, but they work, or like other stuff. Hi Rob, have you ever used Polars? Yes. We've used Polars before. I have a YouTube video on it. By the way, someone was asking about time series stuff. If you go to my YouTube channel, if you go to my YouTube channel and look at videos, I have time series ones. Right? So these are the ones I would start if you're doing that. Whoever said that they were working on that problem where they were trying to forecast like the gym usage, might want to watch these. Someone asked about Polars. Yes. So Polars, I have a video on it. It's kind of just like an intro to it. Polars is written in Rust, which is pretty cool. It's very fast. So I don't want to actually do PCA stuff. So let's do Polars. So we talked about if we open up this tips CSV in pandas, we have a pandas data frame. But Polars allows us to do the same thing and can be a lot faster. So it has a lot of the same functionality. Syntax is pretty different. It's more like Spark syntax. You can already see that just viewing the data frame looks a little bit different here. But it is a data frame. So if I do a type on this, it's just a Polars data frame. And then Polars does let you quickly just jump back to pandas by just running this to pandas. Now we're back into a pandas data frame. So if we go here to some examples, there's a lot of stuff that I talk about on that video, but its ability to read lazily is also very helpful. So the thing about with pandas is every time you execute one of these lines of code, it's transforming and manipulating the data as it runs that line of code. With, that would be with this. In Polars, the big advantage, one of the big advantages is that you can load the data in lazy mode, which basically just says, I want to do this operation eventually, but I'm also going to do all these 50 other operations. And then at the end, you say execute, and it can optimize all that work. It makes like a DAG, like a graph representation of what you're trying to do to all the data, and it can do it in a much more efficient way. That's one thing, but it also does a lot of speed with multi-threading because Polars is written in Rust, as we mentioned before, and it's just faster because it's written in Rust. Did you make sure your data is a tidy each row observation of column? Yeah, no, not always. I know the whole tidy philosophy, but I don't know about it enough that I've strictly make my data that way. That sort of stuff is, it's big in R, and if you code in R, and I know that it's also important when you kind of have these smaller, medium-sized data sets. Talking about PCA, I'm working on a classification project with MNIST using support vector machines. But the results are very long process overall. And when I use PCA to help the process, I think it's longer accuracy. Yeah. So PCA, you're going to lose information regardless. PCA isn't as popular as it used to be because it used to be that you try to reduce the dimensionality of your data first in this pre-processing step so that it would be easier for your model. But you can actually just deal with that with the model itself, within the model. So it depends on the size of your data again and what you're trying to do. But one thing with SVMs is I know that if you run it on, that's one thing that I know that Cutif has support vector machines support for support vector machines, and they can be pretty fast when you're running them on a GPU. So maybe check that out. So the data focus around harvest results and tasks to understand the post-harvest loss. There are two data sets, both 15K columns, one harvest data. Not you said. It's funny that you said that this is a huge data set with 1,500 columns, because it's actually that's like more on what I would consider on the small size of data, because the more complex your models are, you need to have the data to support it. So I take that back. It kind of depends on 1,500 could depend on the type of data, but it sounds similar to Dask. Yeah, I think Polars is like a Dask killer, because I've never had good experiences with Dask, and the idea makes sense, but I've always had better results just taking pandas and trying to parallelize my processes on that. So it's hard for you to get a great score if you use SVM on MNIST. I mean, if you're working with MNIST, it's such a common problem that is used, that you can just go to Kaggle and see, like, this is the MNIST data set as a Kaggle competition, and you can see what, like, these people cheated. That's why they get perfect scores, so ignore them. But you could see what sort of models people use to get high scoring results. Score of 22? That doesn't make sense. So maybe look at some of the most upvoted models, and you could see, like, this person made a Keras model. Could be leaky. It could be leaking the target. But you might learn some stuff just by reading this. I'm sure there's a notebook out there using SVMs. So someone made an intro to dimensionality reduction. They might have SVMs in here. Yeah, I would look at this stuff. Like, it is a treasure trove of stuff. You need to be able to decipher what's BS and what isn't. Besides that, there's a lot to learn from. Tutorial on feature transformation would be great, like log, box, Cox transformations. Yeah. Hey, Simon, thank you for subscribing. I missed that earlier. PCA is great for visualization. Yeah. Yeah. Usually for visualization, I use TSNE. TSNE, I don't know. It tends to make them a little bit prettier looking. I don't know what else to say. Especially if you want to do like 3-dimensional clustering. It takes a little bit longer to run. I think there are GPU implementations. And what else about it? So this is using the MNIST dataset and running TSNE. You can kind of see each cluster for each of these digits. I love your YOLO V5 custom video. Oh yeah, thanks. That was the one where I did a chessboard. It's very helpful, so thank you. Although I stumped on duplicating my data with noise included, or smooth the image and then train the model for better accuracy. That's the one thing about YOLO, is it has built into it a lot of augmentations already that are good for object detection. So it's going to be hard to, I've had a hard time finding more augmentations, which is what you're talking about, duplicating my data with noise included. That's considered augmenting the data. And since YOLO already has that built in, you're going to have a hard time doing a better job. Hello, I have a question about Kaggle. Since you are a grandmaster, do you have to read papers for every competition and apply them? Or do I try to come up with something new? You don't need to come up with something new. You can just start with the public notebooks, which are usually good. It depends on the competition. Reading papers isn't bad, but usually it's going to take a mix of both. And I also know Kaggle grandmasters who have said they don't read papers at all. So really each person will approach it their own way. And the main thing is figuring out what way works for you, right? Let's say I have to use SVM because part of my Masters 2 lectures, I'm only restricted. Well, if you're restricted to use only SVMs, then you got to do it. Not sure what you're talking about. ST. Yeah, that's the harvest one. Okay, so the data. Oh, this is the 1500 columns. Gotcha. Okay, so I was misinterpreting this earlier when you said 1500 examples. Well, I was reading this as 1500 examples. Yeah, that's a big data set then. Yeah, you could do like feature reduction. You can do leave one feature out reduction. That takes a while, but my teammate on a Kaggle competition right now made this library, which he uses to win a lot of Kaggle competitions. It's a way of, instead of doing dimensionality reduction, it's a way of removing features that are just not useful at all, and doing that through whatever model you want to use, LightGBM. And you basically can read in the training data, and then it trains a bunch of model by dropping one feature at a time, and then it tells you how much that impacts the score. And a lot of times you'll find that noisy features actually negatively impact your model more than adding the right features. So that's what I'll say about that with your large feature problem. Just stop by to say thank you. Hey, thank you, troll. You're not being a very trolly. You're being just kind and nice. Maybe you can flatten it, use a conv1d and SVM. Yeah, there's a lot of things you can do. What's my go-to pre-processing for non-stationary and volatile time series data? I don't do a lot of the forecasting stuff I've done is more stationary, because aside from that, it's very hard to get a good model that can work on volatile data. Like, let's go to the stock market. Yeah, let's figure out how to download it. I know there are a lot of different ways to do this. What I'm trying to show you is just that, like, a lot of what people think they can do with financial data specifically, or what they show that they can do on streams and stuff, is complete BS. So you got to watch out for that. You got to watch out for that. So I'm going to install this YFinance package, which will let us download some data. No module named. It's because it's installing. So we took the Microsoft ticker and we're taking all the history from that. So this is monthly data. Let's take the close. And what shape is this? 23. Okay, so we want to have Okay, 365 days. So this is just going to be like 1 year of Microsoft's price. Obviously, if you know Microsoft's stock, if you've been following it, you're going to know. But this is non-stationary. Like it doesn't necessarily have, let's see if we can do 720. All right, so let's do 2 years of data. So this is not stationary in the sense that it doesn't have this annual trend. It's not like we're forecasting the sales of cars or something, the sales of a product. We're trying to predict a stock price, which is going to be volatile. At this point, look at this. Can you guys tell me in the chat, without looking up the Microsoft, up until January 1st, 2024, this is what the stock look like. Is it going to go up or down? Is it going to go up or down? Is this stock going to go up or down? Everyone in Twitch, let me know if you think this stock is going to go up or down. Down? I thought stonks only go up. Okay, so a lot of people saying down. Triangle method, whatever the heck that is. That might be BS. You cannot predict from a graph. Okay, so if you can't predict from this graph, I'm not a believer in reading tea leaves. Yeah, if you can't predict what it's going to do because of this, why would you think a machine learning model would be able to figure it out? It's not going to figure it out. There is no pattern or trend that it can figure out. Now, maybe in the very short term, you could figure it out if you had some stronger signals, but just taking this stock price and feeding it in, you're not going to be able to figure it out. Now, if we plot on the same axis as this, all of the data. Wait, hold on. Oh, shoot. Yeah, we don't know because this is up until now. Yeah, I accidentally did it to now. So I was trying to do just like this. All right. If we had just this data, is it going to go up or down? And we wouldn't know, or I don't know. But up until then, yeah, it ended up going down and then up. But it's very hard to tell. So anyone who has like a video or is telling you that they have the algorithm to figure out how to predict this stuff, they're probably either lying to you or they're really stupid. Because if they had that predictive algorithm that could know the stock price just using historic stock prices, they would be making money by keeping it to themselves. Fire up the time machine. Yeah, we need okay, look at this video a year from now and let's see if Microsoft went up or down. That's another hard thing about this time series data. What type of IDE are you using, by the way? Your Jupyter looks clean. Thank you. I'm using just Jupyter Lab with a solarized dark theme, and I have a whole video on my YouTube channel. You can see the link to my YouTube's over there. And yeah, whole video about my Twitch, my setup. All right, before I end here, we've been streaming for a good bit. This has been a lot of fun. Maybe we should do these midday streams more. Before we continue on, or before I leave, let's try to do one of these problems. Where was it? Leak code. Oh no. Okay, let's see if we can do this. Move this a little bit over to the left. This is supposed to be an easy leak code problem for, let's put this over here. For creating a data frame. Write a solution to create a data frame from a 2D list called student data. All right. Return PD data frame student data. So taking a list in will create a data frame. And we want the columns to be student ID and age. Is that going to work? Accepted. Oh, we did it. We passed the leak code problem. It's not the fastest. Maybe the fastest would be... Will it let us import polars? No, I actually don't know how we would speed this up, honestly. Like, some people are able to get it. Oh, whoa. So it's actually slightly faster to make the columns like this and then split it. That just seems random. A lot of this, though, now you can just use ChatGPT or GenAI to do. That was fun. Let's see what the next one is. Did it save that? All right, this means I finished it. Shortcut to comment more lines. The shortcut is like you can select everything and do Control \. It will comment everything that you're selecting. Get the size of a data frame. Write a solution to display the number of rows and columns of players. So, okay, so players is the data frame. So we just want to return the shape. Please pass. Oh, it failed. What? Oh, it wants it as a list instead of a tuple. So this, by default, will return a tuple. We can make it a list just by doing that. Yeah, so this is one of the faster solutions. What else would you do than this? I guess you could do, so if you're a newbie, you might do this like length of players. You could do the length of players and then the length of players.columns. This would be like a bad way of doing this. That still would work. Slow way. But it still was pretty fast. So what are all these people that are taking? Okay, yeah, they're making a list and then appending it. No reason to do all that. Yeah, this is the fastest way. Okay, what's the more faster way? Okay, so this is actually as faster as the way I thought would be slower. You learn something new every day. I want to do one more. Display the first 3 rows. Return employees.head 3. Right? That's going to give you the first 3 rows. Head command gives you first number of rows, and then you give it a number, and that's 3. What did fast people do? This is the exact same thing as what I did. So it's just the randomness of the runtime. Select data. Write a solution to select the name and age with student ID. Okay, so this is a little bit more complicated. We have the student's input, and we're returning. We can do this a few different ways. Let's use the query method because it looks better, but I know it's slower. And then we're going to return name and age. Let's see how this works. All right, so that passed, and it's on the faster end of the results, but I think it's going to be faster to not use query and instead do slicing. So this will find the row where student ID equals 101. And then we can just return this like that. Let's see if this is faster. Please be faster. I think it's faster. In 90.96 percentile versus... yeah, this, which was a lot slower with query. Seems kind of random. Like it needs to run it 20 times for us to get a good idea. All right, everyone. Thanks for watching the stream. If you haven't checked out my socials, we also have a Discord channel. !Discord will give you the link. Hopefully. If not, find it in my YouTube description. I'm going to try to do some of these day streams a little bit more. And I appreciate you all asking questions, joining on Twitch chat, and just all around hanging out. Let's go ahead and raid someone since we have like 50 people on Twitch, which is fun. Let's find someone to raid. Not a lot of people online. Maybe that's why people are watching me. I don't know. Any suggestions of who we should? How to learn the code in 4 months? Melky, let's do it. Let's raid someone who has more viewers than me. All right, if you're on Twitch, you're going to be sent over here. So let's go ahead and raid. If you're on YouTube, make sure you follow on Twitch and vice versa. Thanks, everyone. It's fun. See you next time. Rating in 7 seconds. Bye-bye.